Focus you.
Oh, yeah. Oh, you're doing that too, aren't you?
Mm-hmm.
So I just got this skull today, which breaks apart into pieces, which are the separate bones of the cranium. But they're really pretty crude, but they're better than nothing.
Okay. So our number one was frontal.
Frontal bone. So that would be well, yeah.
Okay. Glabella.
The glabella is, more than anything, it is a radiographic landmark. It's kind of this little space placed right there in between. We have the eyebrows there, and it's the little space right in there, the glabella. You only see reference to it really in a class on radiographic positioning. So,
Orbital surface.
okay, the orbital surface,
And supraorbital foramen.
the supraorbital foramen,
Okay. Frontal sinus.
frontal sinus, shows up best on my backyard skull. And look at that.
Mm-hmm.
Rather extensive. You get these delightful headaches, you know.
Zygomatic process.
Okay, the zygomatic process would be right here, the part that articulates with the zygoma. What did I just do with that? So that would be the zygomatic process.
And frontal crest or spine.
The frontal crest is on the inside, and where do we see it best? Yeah, it shows up nicely on here. Rather pronounced little ridge there. Separates the two halves. Remember on that one picture I had where the back had been taken out of the skull and we were looking forward, you could see that big frontal crest up at the front end. That's it right there.
The left and right parietal bones.
The left and right parietal bones, the yellow. Okay. Not much to say about them, really. They're parietal lobes of the brain, just like they're frontal lobes of the brain, occipital lobes of the brain.
So is it going to be left according to the actual skull or left according to the onlooker?
It's always the patient's.
It's the patient's, okay.
Yes, the patient's. You always want to keep that straight, because if you become nurses, you'll be writing assessments, and you don't want to mix up right and left. Because very often, the doc will be in a hurry, and he'll just copy what you say on your assessment.
Coronal suture.
Okay, the coronal suture is in the coronal plane. These are synarthrosis, aren't they? Fibrous joints.
And lambdoidal
The
suture.
lambdoidal suture is in that. Lambda is the Greek word for L shape. They don't look very L-shaped to me.
Sagittal suture.
The sagittal sutures in the sagittal plane separates the two parietal bones.
A squamous suture.
The squamous suture
Squamous suture.
is right next to the squamous part of the temporal bone, which would be there.
And sphenoparietal suture.
And the sphenoparietal suture is only about a centimeter long. It is between the sphenoid and the parietal bones. Sphenoparietal suture. This is the one I ask most often.
So now we go to temporal bones.
Temporal bone. I had this beautiful temporal bone in the drawer over there. If anybody finds it, let me know. I've got this really kind of crude one. Maybe I'll give it a try. Of course, you're far away. Maybe you can't see how hokey this really is.
Squamous part.
The squamous part is the
Squamous
flat part.
I always say it wrong. Zygomatic process.
Zygomatic process.
Mandibular fossa.
The mandibular fossa is just anterior to your ear hole. So it would be right there. And have a little plastic cup so the mandible can articulate in there.
External.
So maybe this would show it better. Yeah. So just anterior to the external auditory meatus, we have the nice fossa, which is the mandibular fossa into which the condyloid process of the mandible fits.
Okay. External auditory meatus.
External auditory meatus. Not supposed to do this, are you? Except with a Q-tip.
Styloid process.
Styloid process, the three stylo muscles attached to.
Mastoid process.
Mastoid process, the attachment for the sternocleidomastoid.
Carotid canal.
The carotid canal. So what's the best place? Okay. So we get into these really important holes, and I always start with the jugular foramen. It's this really irregular one. Veins are often collapsed. They're not round. The jugular vein is a very large vein. It completely drains the brain. And it's collapsed, and you can see the oblong shape of this jugular foramen. This is the one I always start with, okay? And once I orient myself there, I can easily look slightly anteriorly to see the carotid canal is right in front of it. Okay. So, and the carotid is an artery, so it's not collapsed. And so it's nice and round. It has a good healthy blood pressure in there that holds it in the round configuration. Veins typically have a blood pressure on the order of 7 to 10 millimeters. So they're usually collapsed. Sometimes if you look at a slice through a vein, you catch it at a place where it's totally collapsed and you don't even see it.
Okay. Foramen lacerum.
Foramen lacerum is this one here. They're medial to the other foramina. Some rather minor blood vessels go through there.
Jugular foramen.
Jugular foramen was that first one. the big oblong one that's most posterior of all the foramina. Excuse me.
Petrus Ridge.
Okay, the Petrus ridge
Petrus.
of the temporal bone is the densest part of the cranium. Well, it looks like that wants to come on. Let's use this. So the Petrus ridge, densest part of the cranium, contains all the organs of hearing and equilibrium are contained inside that. That goes to show you how small the organs of hearing and equilibrium are, that they would fit entirely inside the Petrus ridge of the temporal bone. Okay.
The next one is occipital bone.
The occipital bone. I kind of like this one. Showing you how nicely it rocks. Of course, then you can't see the occipital condyles, by which it rocks back and forth on C1.
So the first is the external occipital
Your
protuberance.
smart bone. This guy isn't very smart.
Right.
Okay? And you can palpate that easily on the back of your cranium.
The left and right occipital condyle.
Okay? And you can see them here. Articulate with the superior articular facets of C1.
Jugular process.
The jugular process is the little bump behind the jugular foramen. So we have the jugular foramen, and there's this rather pronounced ridge behind the jugular foramen called the jugular process.
Hypoglossal canal.
The hypoglossal canals are located on either side, and they show up nicely here. On either side of the foramen magnum, there you see, and there you see, and the 12th cranial nerve, the hypoglossal nerve, passes out through that. We'll be learning, the first lab next quarter will be the 12 cranial nerves. Okay. Very cool.
Foramen magnum.
Foramen magnum is the big hole.
And next is the sphenoid bone.
Okay, and before tonight I didn't have one, I was just lamenting the process. Now we have this really crude one, it's so much better than nothing. So, here we see it, and you're looking at it from the front, okay?
Okay. The body.
So looking at it from the rear is maybe more revealing, at least now, for now. The body would just be this part here that I never asked.
Sphenoid sinuses.
The sphenoid sinus is right in the center of this. You can't see it. But, so I'd have to show you a slice, like that CT slice or MRI slices, show it nicely.
Sella turcica.
Sella turcica, the Turkish saddle, down in there, most protected place in the body. It's where the hypophysis dwells.
The posterior clinoid process.
Okay, so the posterior clinoid processes are those two bumps,
Okay.
and the anterior clinoid processes are those two bumps.
Let's see, the lesser wing.
Okay, the lesser wing is this part up here. And the greater wing is that big part down here.
And then you pointed it out already, but the anterior Clinoid,
anterior clinoid
clinoid
process.
process. Okay. Optic foramen.
Okay, the optic foramina aren't shown to scale really, but there are these little holes here, teensy little holes. My goodness. Okay. You see one on each
Okay.
side.
The greater wing.
Okay, and the greater wing is just this huge part here.
Foramen rotundum.
Okay, so we got the three holes. I'd like to start with the back. The foramen spinosum is the little one,
Okay.
way back here. The foramen ovale is the oval-shaped one. Rotundum means round. The foramen rotundum is the round one. And two important nerves go through the top two branches of the trigeminal nerve. And the middle meningeal artery goes through the foramen spinosum.
Is that a posterior view? Right
So
there?
this is a top view that I'm
Oh.
showing you now. So it's good to take this in your hand and look at it in all ways.
The orbital surface.
So the orbital surface would be this part that forms part of the orbit. And you can see the supraorbital fissure cuts through the orbital surface. And the supraorbital fissure is what you see when you look in the orbit and you see the little slit way in the back of the orbit. You see the supraorbital fissure of the sphenoid. Okay? All sorts of things go through there, like the ophthalmic branch of the trigeminal nerve, the ophthalmic artery.
The cerebral surface.
Okay, the cerebral surface would be this part here.
Can you turn it a little bit over here, over this way? I mean, turn your body over. Yeah, there you go. Okay. Okay, temporal surface.
The temporal surface, well, maybe I'm asking too much of this poor little guy. Huh. Having trouble finding both the cerebral surface and the temporal surface.
You could cross them out.
The cerebral surface, oh, I could find them on other models. Why don't I do that?
Oh, okay. Oh, darn.
So this, okay. So here we're looking, the yellow bone is the sphenoid. So this would be the cerebral surface up here. And this is the temporal surface down here. And the orbital surface can be seen inside there. Okay, so the sphenoid is yellow. And you see much more realistic views of the optic canal or optic foramen coming in at a 45-degree angle because those optic nerves are going to cross right over the top of the sella turcica.
So.
Really cool anatomy, and you see the foramen spinosum and the foramen ovale and the foramen rotundum and the supraorbital fissure. Okay.
Pterygoid.
Okay.
Pterygoid process.
So where this becomes useful is it actually shows the pterygoid processes, which are the legs of the butterfly.
Okay. And then.
And you can see that the pterygoid processes articulate with the posterior aspect of the maxilla. I'm looking, this is upside down, but you can see the pterygoid process on each side articulating kind of with the palatine bone and with the maxilla. So if you ever wondered what was behind the palatine bone, now you know.
The pterygoid canal.
The pterygoid canal is a little canal that shows nowhere else but on this model I just got tonight. So pterygoid canal is a little hole there and a little hole there, pterygoid canal. And I've tried to figure out what passes through the pterygoid canal. Haven't figured that out yet. I'm working on it. Kind of.
Dorsum sellae.
The dorsum sellae is the back of the saddle. One of my favorite things to ask.
And what did you say that?
It shows up very nicely if you're looking at slices, axial slices through the cranium. You know just where you are if you slice just barely into the top of the dorsum sellae. Okay? You know, you can orient yourself then. You know that you're just above the pituitary.
Okay. Ethmoid bone.
Okay, the ethmoid, closely associated with the sense of smell. It's up here, shows up very poorly on models. And as far as picking out the conchae, well, is that what's next?
Next is perpendicular
The
plate.
perpendicular plate, so you can see the perpendicular plate. And remember I told you that the nasal septum was made up of contributions from the perpendicular plate of the ethmoid and the vomer down below. Okay. So you can see the perpendicular plate. I like that picture, that coronal slice through the conchae. I can get an awful lot off that because we see the conchae and we see the nasal septum, and you can even see the articulation between the perpendicular plate of the ethmoid and the vomer.
Crista galli.
The crista galli shows up best on my backyard cranium. There's a beautiful crista galli on there, right there. And the brain attaches to this, and it anchors the brain. Is the next one cribriform plate?
Yeah.
This is the best cribriform plate you will ever see. Okay, and you can see really what a cribriform plate really looks like, and you can see all the little holes in there. Those are all little olfactory nerves that go through to the roof of the nasal cavity, and all your olfactory receptors that you smell with are located on the roof of your nasal cavity, and the little nerves from those pass through and attach to the olfactory bulbs of the brain, which lie on either side of the crista galli in the cribriform plate, the region known as the cribriform plate of the ethmoid. So this cribriform anatomy, at least superiorly, is shown better on this than anywhere you'll ever see. So that's very cool.
And air cells?
And the ethmoid air cells, well, they're inside there. They're kind of like little sinuses.
Superior nasal concha.
Superior nasal concha shows up on no model that I know of. Well, maybe here. Okay, I take that back. Superior, middle. The superior and middle come from the ethmoid bone, and the inferior nasal concha is its own bone. It's a separate bone by itself.
Okay. Then the vomer.
The vomer, I actually have one. Talk about an obscure bone. I could get all the obscure ones, it's just the important ones that I can't seem to get. That's what a vomer looks like, and it articulates with the sphenoid bone. Okay, and kind of sits in there like that, where this is the horizontal line. Okay, this is horizontal, and this way it would sit right against the roof of your mouth. against the hard palate down here. And up here, we'd articulate with perpendicular plate of the ethmoid up here. And then this part over here would be cartilage to make up your nasal septum. And vomer is the Latin word for plow.
Okay, and then this one you did already, but inferior nasal concha.
Inferior nasal concha is just its own bone.
So, and you've got right and left on there.
Yeah,
So is that
right and
gonna
left.
matter? So,
Okay, so I'll show you a right and a left, and you gotta tell me which one it is. If I could, I used to have one of those separate, the real bone. I forget where I got that.
okay, so then we have three muscles.
Three muscles that are really easy.
Frontalis,
Frontalis, guess where that is? And temporalis,
temporalis,
and
occipitalis.
back here would be occipitalis.
Okay.
Hold your head back like that.
That's it.
Piece of cake.